We're fucking
Cool.
ready. Okay. It's always good to start fashionably late, and it is a code and chill session. So I think part of it is all for us to hang out and meet each other and learn what we're working on. Make friends are great. Potential collaborators. You guys might make like the DeFi games of the future.
Yeah, hell yeah. It would be a shame to do zero chilling in the coding shell. That would just be wrong.
Yeah. Mm. All right. Can everyone see that? Is the font super? Is that good font size? Or
Maybe a little bigger, slightly bigger.
how about that?
That works for me. It's nice. It was good.
Sick. All right. So we now have a new code and chill repo, which I will paste the link for in the chat. So if you want to play along, if you want to try tackling one of these issues yourself in real time, or if you just want to tweak the code as we're going and go in your own direction, I think that's great. We might as well all be like hacking on this stuff, and maybe you can even share like snippets or whatever in the chat. So this, I do like interactive things. Otherwise I feel like I'm talking to myself, which is I try not to talk to myself.
We'll help you out, man. We'll keep it C-way.
I appreciate that. Appreciate that a lot. But paste in the repo to the chat. All right, here we go. So yeah, that's our little repo. You can clone it and get set up. If you have any issues with that, just feel free to ask a question. But yeah, you basically just clone the repo. I assume you already have Rust installed, but if anyone wants me to cover that, I can cover it. But otherwise, I'm just going to move on. I'm just going to assume you have Rust installed. It's honestly not that hard. You just install the Rust up tool, and it's probably one of the easiest to install languages that exists. You just run Rust up, and it gives you everything you need. I just posted the repo in the live coding chat, so feel free to clone it, and we can all work on it together. Yeah, this is the repo, code and chill. Right now, we only have our contracts folder, and there's only one contract right now. But I assume as we keep coding and chilling, we're going to start adding other folders for other things we might be working on. So we might work on some helpful like tooling packages. I don't think this has to be all Rust specific too. Like Reese, I think it'd be really great to do like a data analytics code and chill sometime where we can just like hack some like Python scripts and like work with actual chain data, or introduce people to indexers. And then I think I also want to eventually put some front end projects in this repo. And then hopefully this becomes a good resource for people to just look at some working examples of stuff.
Also, Strange loves interchain tests. We should get that in this as well.
Oh yeah, there's so much stuff to cover, and I kind of want to just start doing these as often as possible. In fact, I have a plan for that, but I'm going to share that kind of more towards the end. I've been teasing Leet Society for a little bit, but I'll explain what it is. It's going to be hella fucking fun and very profitable for those people that are accepted as members of Leet Society. All right, let's begin. All right, so I guess where were we last time? So this is our CW piggy bank. If you did not join us last time, it is an NFT contract that functions like a piggy bank. So you can put money in like a piggy bank, and you can get money out, but only under certain conditions. A really easy one that we've just started with is deposits can be withdrawn if the NFT is burned. So you can just build an NFT with Juno or regen tokens or whatever, and then those tokens just sit in the NFT until it's burned, and then whoever burned it gets the tokens out. Fun. We've already implemented our like basic NFT contract. If you weren't here last time, there's a really nice template, which we could also link in the chat, or if someone wants to dig it up, it's probably in the history of Dev Lounge. But there's one little command that you can run that will generate you like a whole NFT project. If you want to make your own custom like game NFTs or whatever, that is somewhere in the chat history. Someone wants to find it. And yeah, so we already did that. There's a couple of things that we're probably going to want to start doing today. One thing that I think would be really cool to implement today is supporting multiple types of tokens for deposits. And then I think another thing that would be cool to implement today is changing the appearance of the NFT as more money is put inside of it. So you can imagine, I think the example I like to use for this is like a tree NFT. Let's say this is like an environmental like fundraiser for reforesting the Amazon rainforest, and you have these tree NFTs, and this is just an example, it's not a real project, but They come as little seedlings, and then you have to lock up tokens inside the NFT, like carbon credits or regen tokens or Juno or whatever. You have to lock up tokens in order to grow them into the full tree. So the more tokens you add to the NFT, like it gradually starts changing in appearance. So we're going to talk, I think it'd be good to explore how to do this kind of more dynamic style of NFT today. Unless people are really interested in something else, then we can always change direction. And then I guess finally, I think it would be really good to start getting into some tests, because tests are important. Oh yeah, this is, I'll be probably jumping around a lot. I'm still like perfecting my live streamer coding, so bear with me. This is our project. It has all the normal stuff. We have our source folder. That's where all our code is. We have our cargo.toml folder. The main dependencies we're using is like the CosmWasm standard library, obviously, and then CW Storage Plus, and then also this CW721 base library, which is like all the sort of NFT logic, so we don't have to like implement that ourselves. And so, yeah, here's our contract. Do people want me to, I guess we can just probably cover, I'll try to cover it again really quick, and then we can get on to building new features. I actually did fix a few things since we last looked at this contract, and I'll point those out. But here we import all our dependencies. We set some basic version info that we can use later for migration or just knowing what the hell this contract is when we put it on chain. The NFT contracts have 3 types of extensions that you can build. And there's other ways to do it, but this is the current way. There's the metadata extension. So this is like for on-chain metadata. So say you want to store extra stuff for each NFT. Like maybe each NFT has a certain power or a certain strength or a certain height or a certain color. And you want that to be on-chain metadata. Usually if you want to like interact with that logic in some way with smart contracts. So if it's just purely display purposes, you can use the traditional kind of token URI based method where you just have some JSON and you put it on IPFS and that just has all the different stuff you need. But if you actually have something like, let's say you're building a fighting game and there's like each character has certain attributes and you need those attributes to calculate outcomes that deal with people's money, you're going to want that on chain. So the metadata extension like helps create like on-chain metadata. The execute extension is used to add extra methods to the smart contract that are not part of the normal NFT standard. So the ERC721 standard, which CW721 is based off of, just has all the logic around transferring the NFT, burning the NFT, like all the kind of like standard like NFT stuff. This is for implementing like extra logic, and then query extensions are for implementing extra queries. This is where we actually construct our main contract type here. And this is probably like a little bit scary for some people because we got this is called a lifetime. Let's Get Rusty has a great video on lifetimes. Honestly, usually you don't have to use them too much. And then when you do, oftentimes they're like part of some template and you don't really have to know about them. You just modify the template as is. Yeah. We're not going to get into lifetimes, but you can read about them. They're fun. And they're not that complicated. They just look really confusing when you first see them. What the hell is this little apostrophe A? But anyway, this is our sort of like base contract here. Remember this CW721 base? This is our base library. And there's a struct called CW721 contract, right? And this struct is using what are called generics. So generics are really cool. They allow you to like basically extend a type's functionality. Like again, Rust has a very strict type system. This is not JavaScript. If anything is wrong, it's going to scream at you until you make it right. And that's actually a good thing because we're writing smart contracts, right? We're dealing with people's money. We want as strict as possible. So that's why Rust is great for smart contracts. So when we construct this, we have to pass in either the extensions, or if we don't want to use a particular extension, we can pass in an empty type. And I hope my comments make sense there. I tried to like really comment this template file as much as possible. But if something's confusing to you, or if you have a better idea for how it could be commented, like just submit a PR. And I'm going to be giving away Juno for PRs today. Like, why not? Let's fucking go. And then then we just basically have these 2 execute message and query message here. Pretty standard. This is actually new from last time. If you were listening, we had the problem of needing to make a custom contract error. We had a little type difficulty. So we actually define contract error here. We're going to put all our future errors in this struct. But here is where like kind of the magic happens. So we have, and this is actually, I think, a good thing to talk about a little bit deeper. Oftentimes with Rust, you'll get to a point where you're like, oh, my contract works. Like it's not compiling because I don't handle this error type correctly. Rust is very strict. It makes you handle all, not just the success cases, but also the error cases. Like you have to just handle all the error cases and all the success cases. And then it has a really strict type system. So what this piece of code here is doing is like we have a new CW721 error, and we've got this little like from macro, which is basically, think of this as like an extension of just like the base like NFT contract error. And there's two macros here. Usually the macro syntax is like hashtag bracket thing. We have this macro here, which is error, which constructs like an error message. And this like 0 here, like this could just be a string and we could not have, if sometimes there's a value there. So that'll take whatever the error is and print out NFT contract error and then the error message. Hope that makes sense. Anyway, I'm going to do that a lot today. It's really hard to talk and code at the same time, but I try my best. So yeah, this is a macro. This error macro is pretty fun. And then this is another macro kind of thing where we're basically extending this new error type from this. And this actually saves us a lot of time. So we don't have to do something like having to implement all the different error traits for all the different types of errors we might use. And actually we're doing the same thing here with this from payment error. So we look at payment error, it's up here. It's this CW utils payment error. So we're also just handling those errors as well. All right, so we had some to-dos for ourselves. This is our one item of state, one item of extra custom state. We have balances, which represent the amount of tokens each NFT has. It's basically in the format of like token ID and amount. So each NFT token will have a sort of certain amount that's associated with it. As always, there's 3 main entry points to CosmWasm contracts. There's a bunch of other ones, but the ones that are most common are instantiate, execute, and query. And they're marked by this little entry point query. Instantiate takes our initial message and creates the initial state. That's like the initial state that the contract is set to. Execute, that's your write, basically. So that's when you want to change the state of the contract. Execute takes the execute message and, hey, we defined this earlier. And we look at that message using like a match statement. There's other ways we could do this, but I think match statement is great. I really love this pattern. And we basically handle that message accordingly. So here we're doing an override. So we're doing our own custom burn implementation right here. And here we also implement our extension for the deposit right here. And then aside from those two messages, we just use the default implementation for the rest of it. But notice I did add this little line right here, which is, I'll just delete it for now so you can see what happens. So now it's complaining about incompatible types. Okay, why is that complaining about incompatible types? So we go over here and we go to contracts and CW Piggy Bank and we go cargo builds. Sometimes your editor, and maybe VS Code is better than Emacs, but sometimes your editor will not give you all the information. Like this message just says match arms have incompatible types. But if we go to this, we see like a much richer error message. And we see that it's expecting the contract error as we defined it, but it found the base contract error. So these are actually 2 different types, even though they're named similarly. So again, this is our contract error up here. And this contract error is actually different because it's coming from like the base library. But remember, we added this little like from macro here. Like we've got this little from payment error here. So all we have to do for that is basically this map error. This map error will just, if this execute message fails, it's going to take that error and map it into into. And into is like this other like trait, which is the standard REST interface. There's another way we could write this, which might be a little bit more readable. But basically now what that's doing is when there's an error, it's going to basically call the from method on this error, and it will basically convert the base error message into the error message that we want. So map error is a really handy little, I don't know, Reese or someone, do you know what these are called? I guess it's just like a little method. Yeah, it's just the map error is great for like kind of handling these annoying little like type conversions. All right, so getting into the functionality of our contract, and then we're almost ready to start coding. I'll finish up the summary. We'll ask some questions, and then we'll start like actually implementing like our next features. So execute burn is pretty simple. Here we load our base contract. Again, we have like our little base type here, which we defined earlier. And we have our little base contract. And first thing we got to do, so burn is basically exactly the same as in the base implementation. So this is the base implementation right here. But the additional thing we have to do when we burn the NFT is pay out the piggy bank, right? We can't just use we have to override the burn method because we can't just burn the NFT. We want to burn the NFT and pay out the piggy bank. So here we load the balances. They may or may not exist. If they do exist, we create a bank send message. This is how you create like a custom Cosmos message. And then in the response, we just add the send messages to our response, and that will send them to the right person. In terms of deposit, we just make sure that they're paying the right token. We're going to refactor this today to make this a little bit more customizable or accept multiple tokens. Then we also load our base contract. We make sure that the token exists. This question mark is, we talked about it last time. It's a simple helper syntax to unwrap and a result. So results are just a really common type in Rust that is used all the time, and you learn to love them, especially if you're coming from Go where they don't have these things. They make error handling really easily. They make error handling really easy. So every time you do something, you can get a result type back and then just check whether it was successful or not. And then if it's successful, you do one thing. If it's not successful, you do another thing. But this is just a really simple way of saying, if successful, return that value or unwrap that value. If it errors, just throw an error, which will be our contract error. And then, so we check the token that exists. We update our balances with basically just like increment with the amount, and we return a response. And then for query, we just have our simple balance query where it takes a token ID and we just return the balances for that token. All right, that was basically our whole contract, and I think it works. So actually if we go over here and sweet, awesome, everything compiles. Sick. Okay, before we move on to like our next tasks, I want to just take a little question time, or a little break time. That was probably a whirlwind. It was probably a mix of boring for some people because we already covered it last week, and then way too fast for other people because they weren't here last week. Yeah, any questions or kind of comments before we move on or yeah.
I thought it was a pretty good summary. The comments help as it is. Yeah, like I wasn't here last week, so I think I'm gonna just have to get it as I go. But for the most part, good summary. Well, comments help a lot.
Yeah, and in many ways, like NFT contracts are like a little bit more complicated than some other ones because they use this sort of extension pattern, and they use like traits, and that confuses some people. But there's a lot of really great Let's Get Rusty videos on the Rust type system, and if you watch those, this kind of syntax you see here, where it's like there's a type and then these like brackets, it'll start making a lot more sense to you. And you see this kind of, I think the thing is like a lot of people are like, don't use traits in contracts because it's like too confusing for other people to read. And I get that. And part of me wants to like make another version of EW721 NFTs where we don't use traits, just because I think it would be a little bit simpler to write. But the fact is like traits are like everywhere. Like even if we look at this response type, for example, see this response type also takes a trait. So in this case, like it's set to a default of empty, but So that's why we can use it without having to configure an explicit trait. But there are many times where you're actually just going to have to use traits in Rust, and better to just jump in the deep end and learn how to swim. It's not too hard to learn about traits. If we look at this response type again, we have a struct, right? And it has a generic T, which with a default of empty. And then as we can see, certain types use that generic as if it was another type. I mean, we could just, what's happening? So yeah, generics are just really useful, and they're like basically all over Rust. So there's no way you're going to come across them at some point. You might as well learn them. But yeah.
One other quick comment before we move on, just for the organizers. I'm not sure if the actual event that's on the Discord was officially started. And I think the people who are otherwise interested in the event, like the Discord event itself, should get started, because then they'll get notified. I know it's a bit late at this point, but
I just started it, and thank you for letting me know, because I didn't know about that.
Oh, good. I think maybe some people get notified. I think that might be the issue why some of the interested weren't. They could let know. Yeah, no problem.
We're always learning new things, and I'm learning how to live stream coding sessions. Oh, see, now more people are joining.
Yep, there we go. It's happening.
Yeah. The thing is, like in life, a lot of times you just don't know what you're doing, and you just only learn by doing it. When I started coding, I had no clue what I was doing. You just keep doing it, and like eventually you figure stuff out. And I guess streaming is like that as well. I don't know what I'm doing, but I'm figuring it out. I've got OBS running. I just realized that when you do a Discord event, you actually have to start the event. I'm learning so many great things.
They roll it. Let's go. Yep.
Cool. All right. Any preference for what feature we want to start next? I guess maybe we should just do a bit of cleanup. And I think there's these balances here, right? And right now, it's just taking a single amount, basically. So most tokens amounts in CosmWasm are uint 128, which is a very large number. And so yeah, it's basically, yeah, just taking a token ID and storing an amount. Now, perhaps we want to support multiple tokens as a deposit. There's going to be some issues with that, and I'll explain what they are in a bit. But another thing that we've done is, as you can see, we've totally just like hard coded a particular token in here. And this is probably like the first, we don't want to do this. So I guess right now we're at like let's just do one thing at a time, and we'll just keep refactoring until we support multiple tokens. But let's first make it so that we can not hard code everything to you, Juno. Like maybe you have a specific token factory token, or you want to use like an IBC token like regen or carbon credits going along with like our NF trees idea. So let's make it so that we can customize what the denom is. And to do that, we're going to introduce another piece of contract state. So we're going to define a new piece of state. This is going to be constant as well. We're going to call it allowed denoms. And this is going to be an item. Maps we talked about last week. A map takes a certain value as a key and then maps it to a value. So this is really useful when you have like many of something. Like there are many token like NFTs in an NFT contract, right? Or there might be many accounts in like a DeFi project, and you want to map an account to its balance information. Items are basically just one-off single piece of storage. So when there's an item, there's really only one of it, and it's just itself. So it's different than a map. So for this, we're going to do just a vec of, let's do a vec of strings. Why not? We can optimize this later. And we're going to make a new item. The syntax for that is basically new. Items take storage keys. These keys are used to like basically under the hood, like each contract has its own little like namespace or key value store. So we're just going to call that denoms. Great. And now we've got a nice little piece of state. But how the fuck are we going to configure this? We need to set allowed denoms at some point, right? Now, one way we could do this is if we were really barbaric, we could not use state like this, and we could just like hard code it in the contract. We could just make pub const denom and then make a comment that people have to change that. But no, we're gonna make it nice. So we've got this nice little item state. We're not gonna hard code anything, but we do need to tell our contract which denoms to use at some point. And we're gonna do that in the instantiate message. So right now we are using the default CW721 base instantiate message. And as you can see, this is coming from the CW721 base library. We're going to not use the base implementation. So up here it says we're importing all these things from CW721 base. We're going to get rid of this and we're going to make our own instantiate message. We don't need the base anymore. We're making our own. We're going to put that right here with our other stuff. Already this file is starting to get long. So at this point, we'd probably consider maybe reorganizing, but we're just going to keep it all in one file for a little bit longer. So this is our instantiate message. We take the name of the NFT contract, we take the symbol of the NFT contract, and then we take a minter, which is the person who's allowed to mint and create new NFTs. And now we're going to create our own placeholder for the value we want to pass in. So we're just going to add a little comment here, allow denoms for deposit. I just realized I don't have GitHub Copilot on this computer, and I realized I miss it. God damn. I never thought I would say that. And we're just going to also make that just like a vec of strings for now. Might go up. We might revisit this stuff. It's always okay to revisit. All right. So now like we're going to get some errors. So if we go over here, oh, wait, it's because I didn't save it. That's why. All right. Now we've got like a lot of errors and we've got a lot of type errors. So let's go through like fixing some of these errors because we need to fix them. All right, so here's the first one. Expected struct CW721 base instantiate message found struct instantiate message. Does anyone want to try their best at what's going on here?
That's because we're using like default. We're not using we're using the default instantiate message as opposed to the W721.
Yeah, exactly. Because this type and the type that this type returns have diverged. Because we're not using the base library anymore. Remember, we added that actual extra field. So this message type right here that we're passing in is actually wrong. So what we're going to do is we're actually going to go back up here to our CW721 base. And we're actually going to re-add that instantiate message because we actually need it. But we're going to rename it as base instantiate message. I'm just naming things as I go. They're probably not the best names, but feel free to make PRs and fix my bad naming. So now we've got this base instantiate message type. What we can do is we can go down here and it's complaining of this type being wrong. Let's give it the right type. We're going to give it all the thing and things. This is where Copilot would be really nice. We're gonna give it the minter. We're gonna make this info. Send. Or wait, no, this isn't the message. So we're gonna make a message.minter. Remember that we already configured this instantiate message with the various different fields. So we're just basically regurgitating that info into the format it expects. So then we're going to add the name. That's just going to be message.name. And then we are going to add the symbol, and that's just going to be message.symbol. And now if we save that fixes all our errors. But we still have some more errors, but I think we're going to like just finish up a little bit. That's later on in the file. So we're going to finish up the instantiate part and then we'll move on. We still need to set this allowed denoms piece of state, the state item that we just created. So let's do that now. We're going to do allowed denoms, save. We pass in our storage dependencies. So in CosmWasm, we have all these kind of default arguments for entry points, which are dependencies. So this is like your access to the API, storage, all that stuff. Environment, this is things like the contract address, block height, etc. Message info, this is info about the particular message, like who sent it, how much fees did they pay, etc. And then the actual message itself. So yeah, we do allow denoms.save, and we're just going to do message dot denoms. And it takes a pointer. We're also adding the question mark because we want this contract to fail if this fails for whatever reason. Very low likelihood that this fails, but we want to make sure we handle as many cases as possible. In general, if you're using CW storage stuff, let's always do this. Always just check. You never know. So this is great, but I feel like we've missed something. What have we missed? Any takers? Is this good enough to ship? Just look, forget all the, just looking at this instantiate message, this part of the code. Forget the other errors or the other parts yet. Is this instantiate message good enough to ship now? Is there anything else we want to do? Question for the crowd.
We should probably check to make sure that they at least inputted one allowed denom minimum.
Yeah, we have to validate that shit. Yes. So we're going to do, let's just do it now.
We can make it an option and then just by default set it to the Juno since it's going to be launched on Juno.
Could do that, but maybe we want people to like think explicitly about this. But yes, in general, whenever there's something like this and it's a vec of strings, you have to think about what happens if someone, they include the field, but they like, it's an empty array. They don't like, they don't actually provide any denoms. Or what if they provide like a denom that's like, just like really fucked up? Because again, remember, this is coming from JSON. Rust has a strict type system, but JSON does not, okay? So we can't really, it's hard to represent like a valid denom in JSON. It's just a string. So we actually have to do some work to like make sure it's not a string, like the beginning of like Shakespeare play or whatever. Actually, I'm going to make this a to-do because we can make this, let's do some richer validation here. But the basic thing we could do is just make sure that there's like a, let's just write out the list of stuff. So we want to validate at least one there's at least one denom, right? Okay. And this is really, actually, this might seem trivial, but this is like a really important part of smart contract development. Actually, one of the most important parts. A lot of it at the end of the day is just like passing messages and then like saving stuff and updating stuff and loading stuff and deleting stuff. It's basically CRUD. But like the real art of smart contract development is thinking around like the edge cases and like validation. We want to validate that there's at least one denom. We want to validate denoms are formatted correctly. We want to, I think another thing, I'll just talk about it a little bit right now. But remember, okay, so this takes an allowed denoms here, okay? And it's a list of strings. There, as it's expressed in the types right now, there is not any limitations on length. So if we're thinking about attack vectors, which I know everyone loves to think about, how might that be used to like actually make it impossible to cash out your NFT? Anyone have any thoughts on that? What if I like Reese has a really cool NF tree and I get in a beef with him for whatever reason? I love Reese, just for example. What if I sent him like thousands and thousands of like token factory tokens or just, and then now he's got 1,000 tokens like in his NF tree. What would happen is down here, we're probably gonna have to do some logic to like pay out multiple tokens according to denoms. And then we could easily get into some issues with like gas, basically. So that's something we just have to be mindful of because we're going to refactor this to not hard code here. And at some point, it's going to result in just like a list of send messages. And if there's too many tokens, that list of send messages is going to be so big that it runs out of gas, which could be like a denial of service attack. We can talk a little bit more about that, but if anyone has questions about that, feel free to ask. But we also It's very important to think about what your data could be and what the bounds and checks on that data have to be.
Does this idle that you're setting up, do they have to be unique? The denoms?
Oh, yes. Oh, fuck yeah. Hell yeah. Okay, great. And you can also see like the implications of a simple design decision. For example, like if it's just allowed denom, just one, our contract becomes a lot easier. In fact, we might even go back and refactor it to just do allow denom first and then the whole list. But even just a simple thing, like instead of taking one string, we take a list of string. Look at how much like extra kind of stuff we have to think about from that like kind of one decision. Always keep in mind that sometimes simplicity is your friend. Like we don't want to like over engineer stuff. So yeah, we want to validate that our denoms are unique, because that could also be a potential attack vector depending on how we implement it down here. Like if we did something really stupid, that could allow, let's just say we didn't do this unique check and I create a contract that has like Juno listed twice or even 3 times. And then there would be like 3, when someone burns their NFT, there'd be like 3 bank messages to send Juno. And that means that like whoever burned their NFTs first would get 3x the Juno, and then people that burned later would not. It would break the economics and the trust of our whole contract. So that was a really good point. Who brought that up actually?
Cheddarman.
Fuck yeah. Send me your Juno address. That was a great comment. And then who brought up, wait, what was the other one?
My name's Clyde.
Clyde. Also send me your Juno address.
Those were great.
Honestly, this is the kind of thinking that we have to do as smart contract developers. And then sometimes when you're doing this and you're like, validate at least like one denom, if we just made this a string, we don't have to do this, and we don't have to do this, and we don't have to do this. So we just have to check formatted correctly. So this, sometimes thinking about the validation stuff can actually help you like think about the API of your contract. And a lot of times I've found that my contracts get better the more I simplify them. And like sometimes you also risk like building a feature that like you're not sure if like many people will even use. It sounds good, right? To have an NFT piggy bank that takes multiple tokens. And maybe that is a good thing, but maybe it's just not really needed. Maybe one token is fine. But yeah, I guess it depends on what people would want to use this custom contract for. So you might decide, well, fuck it, this VEC adds way too much complexity, I'm going to get rid of it. Or you might decide it's essential to the functionality and then just think through all your different validation cases. Let's keep going, but we're gonna get back here and then start doing some of these validation. And then I think another great thing to go with the validation is that we're gonna actually do some unit tests for our validation. So finally get into some testing. I need to bring this computer Emacs setup to my other one. Oh my god. Oh,
Misspelled.
I know. Oh my gosh.
But where?
Oh my gosh. There we go. That error was solved. So if we build, all right, we're building. Cargo test is going to fail now. Yeah, right. We'll solve that later. All right, let's not hardcode this stuff. Actually, I think a question for the floor. Do we really want to do multiple denoms right now? Or do we want to just do one denom and then get as far as we can with the tests and stuff? Or what are you guys' like thoughts? Can anyone imagine a scenario where we really want more than one? Do you want multiple tokens in your piggy bank? Can you actually think of a good use case for that? Or
Maybe if you're funneling rewards or something, I would say implement the simplest version first, and then we could implement the rest next time.
cool.
Eventually, we definitely want to with the nature of IBC, right? But for starters, it makes sense to go for it.
Yeah, we're going to make it one for now. I'm going to rename that to deposit denom just to make it a little bit clearer. And we're just going to call this just denom. Get a nice little string. Great. Now we can, okay, great. We can get rid of this. We still need to make sure it's formatted correctly, but we can get rid of this. And we can get rid of this. Sick. And then we just gotta rename deposit denom. Amazing. All right, so now let's use that. So this is going to be really simple because now we don't have multiple denoms, but we're going to remove our little code comment here. We don't really need it. We're going to load our denom. The load function basically just takes the storage as a dependency. So we basically just do, for items, it's nice, really easy. We don't really need a key. You just say denom.load, and then you pass in the storage dependency, and we will have our little denom, and we can get rid of this section. It is already a string type. We don't even have to do any conversion there, and we can use a little shorter syntax so we don't have to do like denom. In fact, if we did this, I think the lint checker is going to like eventually yell at us. But that's a lot cleaner. Cool. That's nice. Now we've got like a much cleaner interface there. I'm not sure if this is useful anymore. It's in the history. Fuck it. Sometimes it's like you might leave like comments around for whatever reasons, but they're always in your Git history. You can always find them if you really want them. All right, so we're just going to do the same thing here. I'm actually just going to grab this whole line. I don't have Copilot on this machine, and that's annoying. We're just going to... I'll leave this line. So now we're going to, this basically, we load our denom that we configured when we created the contract. For example, when we instantiate the contract, we would pass in like the deposit denom, which we then store. When we deposit, we load that denom. So if we configured it with Juno, for example, we then make sure using this helper CW utils, and CW utils is a great library with a bunch of nice helper functions in it. There's a lot of great CosmWasm libraries, and keep hanging around the dev lounge and code and chill spaces, and also just the Discord chat, because we're going to constantly start like sharing a lot more helpful libraries and stuff. But this must pay function just make sure that they only pay one token, and it has to be the denom that we configured. Otherwise, it's going to throw an error. So great. Now we're checking that they actually sent the right token, and then none of this really needs to change. I do want to get to this updating the NFT metadata today. I think that'll be really fun. And actually, I think it's good that we are only doing one token, because another thing that we have to keep in mind is that complexity in one area will always like impact like development of other areas. So I think we could have like definitely made it so that we could accept multiple tokens for deposits, but it would also probably make it a little bit more difficult for us to implement this logic around updating like NFT metadata, right? Because it just brings in a lot more questions, right? If we're like charging up an NFT, but I give it like Wawa versus like Juno, there's like a difference in like the value of those two tokens, right? And then we'd have to have like more complexity, like a price oracle or something like that. Whereas if you only accept like just one token, it's like much more contained logic, and there's like less like attack area, if that makes sense to people. So I think it's actually good that we decided to not go the complex route, because now we can actually focus on what I think is maybe like the more interesting part anyway, which is like, how do we create like a more dynamic NFT where the more money we put in the piggy bank, it gradually starts like affecting the appearance. Like that's cool. I might even kill these to-dos. Yeah, later. All right, cool. And let's actually redo our query here. So we've got our balance query, and right now we're just returning a number. I think now that we have a configured denom, we should return a coin type. So let's kind of refactor this a little bit. Now, whenever you're like refactoring like a query or an execute, you can do it like in line of this match message. So we got this match message here, or we could also break it out into a separate function. In this case, I think it's going to be so short that we're just going to still keep it in line here rather than breaking out into a separate function. So I'm going to use the coin type, and we're going to have denom and then amount. I think I can just do this. So now instead of just returning the balance, we're returning a coin type. A real quick comment on doc strings in Rust. Rust has beautifully auto-generated documentation. So when you're actually writing a Rust project, you can just run cargo doc and it generates beautiful docs. And if you want to see them for yourself, just go to docs.rs. I'll share the link, but docs.rs is just like an amazing, like that's the example for CosmWasm. All that auto-generated. They didn't write any of that. So that just all comes from your like code comments and just like the types of Rust, which is sick. These double slashes here are not going to get included in the auto-generated documentation. So I'm actually going to change these to 3 so that if we did run cargo doc for this contract, we'd see a little, I guess this is, never mind, forget that comment. But it is true. If there are 3 slashes, they get included in the documentation. So put that in the back of your mind. It's not that important. But yeah, okay, cool. So now this is a little bit nicer. We're returning a coin type instead of just a number. Then we can see the denom that we configured. Cool. Questions so far before we move on to the next thing? Silence. Everyone's.
But I do just want to add, there is an issue in that query because you're loading directly. It should be a may load because they may not be in the balances on that value, right?
Oh my gosh. Yeah, totally. And then we're going to unwrap or default here. So if the value exists and it doesn't error, we unwrap the result. And then because this may load returns like an option because the item may or may not exist. It's much more important with maps. Actually, it's sometimes important with items too, but it's very important with maps because, like, for example, there might not be a balance for this token ID as Reese pointed out. Thank you. That actually helps a lot. It's really hard to talk and then think. So I love teaming up on this stuff. I appreciate help whenever we can get it. But and also it is useful with items too, for example. So I've seen sometimes people like define an option for an item. Say there's a particular like type of setting that may or may not exist. I don't know. Maybe we have something like that's like a name or something. And then I sometimes see people, we'll just call it gnome, whatever, do like something like this where they have like an option inside the item and then a string. And this is basically never needed. And the reason it's never needed is because you could always just do the may load, which will return an option if it exists or if it doesn't. You basically never have to use option types with items. And similarly, like this is also a little bit redundant, right? Like option uint128 here would be like, because again, you could just use may load and then inevitably what this means is that you then have to do like multiple unwraps. So just save yourself pain. The CW storage libraries have that have a pretty good API and mean that you don't really have to use options in your types like that. Great. Anything else?
So just to sum up, we're using mayload in order for an error to not get thrown in case the value is not there, right?
Yes. Mayload returns an option type, and an option type can either be some or num or none. You can actually even look at it here. So yeah, so this returns the option type. And that option is just part of the standard library. And it's like basically either a sum or a none value. One of my favorite things about Rust is that it has the option and result types, and they're just used everywhere. A lot of languages like Go is also like this, where you have to do all this crazy like error handling stuff, and they don't force you to do it, which also gets you into like really weird edge cases. Rust is no, you must handle all your errors, and that value could not exist. And it just screams at you, and it's great. Eventually you learn to like it. Okay, so we've got this getting into our testing a little bit. Let's maybe write some tests for what we've done so far, and then maybe get on to the next section if people want. So we're actually gonna do like probably a whole thing on testing, because testing is super important. But we're gonna write some basic tests today, and they're gonna be more like unit tests. Eventually, we'll get into all the other amazing testing tools that are getting better all the time you can use with CosmWasm, but just going to do the basics today. I'm just going to do a little cargo watch here. This basically is going to run my tests every time the file changes. It's a little helpful thing, cargo watch. So now it's just running on the background. Every time we save, we'll be able to see. So we're just going to fix this error message here, and we're going to do deposit denom Juno. Yeah, hell yeah, let's go. And we're just going to do into, it's a string, so we could also do toString here. They're the same. Also, it's tests too. Usually with tests, you can just like not have to worry about performance decisions or unwraps or anything like that. Great. Now our test works. All right. So half the battle with tests is also to think about, what should I write tests for? And one answer is you could just write tests for everything. Oftentimes we have to pick and choose our battle. And then even if you have to write tests for everything, you still have to think of what everything is. Exercise for the crowd. What should we write a test for? What's some of the logic above that we might want to like test out a little bit more fully? In fact, let's maybe start with the instantiate message. I guess if we had our valid, we could just do a valid denoms here. Actually, Reese, do you know if there's like a good library for validating denoms? I've seen some in Token Factory.
I do not. I think I normally just write things manually.
All right, that's going to be fun. Let's test. Let's test Mint's NFT. Yeah. Sometimes what I like to do is actually do this. And this is also lazy. I'm not sure if I think it's good for development. Usually I'll write a test like this, which is like happy path. This is a test for me to make sure everything does what I think it does. And that can be helpful in figuring out what other tests that you have to write. And usually there's many different types of sad paths or whatever, but the happy path, I sometimes like doing it as like a first test, because it makes sure that the full functionality of the contract works as expected, and it helps me with developing the contract API. And then usually what I'll do is once I've done the happy path, I'll actually just break it up into multiple tests after that. But sometimes just for ease of writing, it's like nice to do it all at once. So we're going to actually just copy this bit, because we're still going to want to do the same thing. So we're going to want to instantiate the contract. We're going to call this I believe this returns an adder. I actually usually write multitest. That's the actual response. Oh yeah, it's not going to take that. Sorry, this is the part we'll edit out the videos. So this is the response. I think we just have to. So there's two different styles of writing tests, which is there's like the unit tests, which have a certain amount of mocking that you can do. And then there's a CW multitest, which is like my favorite library and preferred way of doing it. And I actually use CW multitest so much that usually I only write unit tests for like math and stuff. So I'm a little bit like out of practice here. But basically, we've got like we're just basically calling the functions of our module directly. If we look up at the structure of this file a little bit, we've got our entry module, okay? And inside the entry module, we've got all our different types of functions. It's exciting. And we've got our mutable dependencies here. So this is what's basically holding our mock data for all this fun stuff, which is great. In fact, let's pull these out. So this is like mock M. We're actually going to pull that out because we need an environment, right? I'm going to make it mutable because I don't know if I'm actually going to change it. I might. So that's going to be env. Mock info is, so basically we're like mocking all the different parts of our message here using the standard CosmWasm testing stuff. And if you go to the docs.rs link I put in the chat earlier, you can actually look at all the different stuff that's included with CosmWasm standard testing. Mock info is for the message info. So here's the address is Larry, and this is like the amount of tokens that are sent. I'm actually not going to pull that out, but I'm going to pull out Larry. I'm going to actually rename Larry to Bob. We're going to make it a constant. Unless people have requests for what else we should call it besides Bob. So we just instantiated the contract here. Now we actually have to like mint an NFT with the contract. So we're doing similar to instantiate. We're calling the execute method on our module, and just to look at it, it's right here. Remember, it's going to expect a message and it's going to match the stuff. And we're in the context of this big module right here. So we're just following that sort of logic. So we're going to pass in our dependencies. It's important to, at least for the mock dependencies, they don't quite have the same API as the other ones, but that's because they aren't mocks. Maybe we can work on improving that, but you have to explicitly state that they're mutable dependencies. Then we'll pass in the environment, and then we'll just do similar here because we don't actually need. Okay, so we've got our dependencies, environment, and message info. We're gonna mint an NFT, okay? That's the first step, right? In order to test this, in order to test our happy path, we need to mint an NFT. We're gonna deposit money on it, and we're gonna burn it. And then we're gonna check to make sure we got our money back. Hopefully we do. So yeah, we're gonna mint the NFT, yeah. And to do that, we're going to need the base execute message. Actually, no. We just need execute message. All right. Probably a little bit messy, so let's just save it. And okay, so remember our execute message, we defined it up here. We take the base execute message and we've extended it with our extensions. And so if we go down here, the main execute message we want right now is this mint message, which you call every time you want to make a new NFT. We're going to give it a token ID of 1. We're going to call this collection elite. Why not? Everyone's like, what the fuck is that? I'm going to explain. I promise I'll explain. we've got a squiggly line here. So we're going to call into, that's going to convert it like to a string. This is what's called a string literal. There's a lot of great Rust videos on strings, so I'll let you read those for more information. But I mean, the great thing about Rust is it tells you exactly what's wrong. There'll be like mismatched types, and usually it'll also tell you like what you need to do to fix it. Normally you would store data, like for the token URI, if you're not familiar with working with NFTs, the token URI is like a link to a JSON document that contains the metadata for the token, or usually it's a link to a JSON document. And this is because it's very expensive to store stuff on the blockchain, or at least it was. It's changing actually now, but it's still commonly used today. So you're going to see this all the time. Usually this URI is stored on somewhere like IPFS. Actually, let's not use example.com. And then we don't really have an extension, so we're going to just do none. Oh. So I'm just going to go fix these things. So that here we expected a string and it got a string literal. So we'll just do toString. And that should fix this error. And here it says mismatched types. So if we look over on the screen here, it says it expected struct metadata extension and found enum standard option, because none is part of the standard option type, as is sum. So that's why we have this sum here, because these are both optional. So we can fix that. We've got our metadata extension up here, but as you can see, we're not really using it yet. We have plans to use it though. So I think we're actually going to keep it in here. But one of the things we could do, if we weren't going to use it at all, we could actually just get rid of it and just do empty here. Or like option empty here. And then that would be a way to not have to deal with metadata extension ever again. But we're actually going to use it in the future. So I'm going to just add it here. And that should compile. Oh, wait. Ooh, here's another great error. So we've got, and this is something that happens a lot with Rust. I'm just going to, we have this value moved here error, and it says use of moved value. So Rust is very smart when it comes to memory and has a pretty novel kind of system that's, I think, pretty unique. I don't think many other languages have this. So without getting too into the woods, a lot of languages like JavaScript or Go, they have like garbage collectors. So they're basically these things that are doing memory management for you. Lower level languages like C+ and Rust and C and some others, they like don't do that for you. And that's why they're actually like more performant. You actually have to think explicitly what you need to do with memory. And that's why they're some of the fastest languages there are. Rust has a pretty unique system where it does not have a garbage collector. It does have this really awesome thing called like the borrow checker, where it's just, we've used a value here and we could have, something might have happened with that value in this context. And now it's also getting moved here. And so this could be a potential like memory error, or like potentially like bugs could be introduced here. There's a couple ways we could get around this. For example, we could refactor this function to take a pointer instead of the actual like object, but the easiest way to do it for, especially for tests, is this little clone. So this is, what this is doing is we've got this environment up here. This is creating a clone of that environment and passing that to this method. And then the error is going to go away because this environment will not be like reused. And so we've fixed our little memory error there. I hope that made sense to people. Actually, there's some pretty good Let's Get Rusty videos on this. You might think this feature sucks, but it's like one of the best things about Rust. And I really wish that like other languages had this kind of stuff. Cool. So we've just minted an NFT and that's successful. Great. Now we should probably send some tokens. So to do that, can anyone think how we're going to do that?
It's a hard coding moment, or is there a smarter way to do it?
Well, this is just a test, so we can always hard code this. But when we're writing the test, so we're going to deposit funds. I wish there was an easy way to have other people give this a try. I need to try out one of those shared coding environments things. But yeah, tests are all about hard coding. I guess let me refine the question. Which message are we going to do right now? Maybe this isn't a good question. All right, this is my fault, guys. I don't know what I'm doing. I'm not like a professional live streamer yet. We're going to basically just do, again, our execute message. We're using the execute function. And we're going to use this little extension. Okay, so we got our extension. And then we're going to take our execute extension. This looks a little bit convoluted from the Rust side, but it's like when you're actually just passing in JavaScript, it doesn't care about the types. And so it's much more concise. So we're going to execute deposit token 1. Let's go. And then we're also going to unwrap that value. And this should fail. Oh, wait, let me fix it. This is expecting a string. So we're just going to do string. This should fail. And does anyone want to, it's pretty obvious why it failed, right? We didn't include any funds, right? We called the deposit funds method and it didn't return anything. Now we could fix this and just actually include the coins here. But this is actually a useful test case, right? We actually just made an error test case. So calling deposit funds without funds errors. Great. And then we're just gonna, so this is gonna, this unwrap here is panicking. And as you can see, it says happy path panicked at call result unwrap on error value. Okay. This is always going to like panic because this will always error as we are not passing in any funds, which is great. Our contract is working as expected. So instead of unwrapping here, we can unwrap an error. And now when we run this is actually going to work because we're actually expecting this to be an error. Let's do it again, but with a different kind of error. So let's actually pass in we're actually going to pass in some money this time, but we're going to pass in the wrong token. So there's actually a really helpful function in CosmWasm standard called coins, which basically is just like a way to like, more shorthand form that constructs the type you actually need here. So basically it just returns a vec basically. And the nice thing about this is it does like type conversion for you. So you don't have to do like the uint 128 stuff and then toString and all that stuff. We can just do, let's do 1,000. And then, I don't know, what's a good meme coin?
You Adam. Yeah, you Adam or UAKT.
Let's go. Oh, that's right. Okay, so this needs to be and then we've got another, my highlighter is taking a while to show up, but all right, so there we go. That works. And I'm actually just going to also just clone this because okay, so we've got two error cases. These would be good candidates for breaking out into separate tests. In fact, You know what? I think Larry was right. We don't need to be cloning this environment all the time. So we're going to do a small refactor here to just make our code a little bit cleaner so we can stop worrying about those stupid clones. And we're just going to call mock environment on each one of these because it returns the same value. I don't think, yeah, it's not like dependencies. Dependencies, we actually have to like reuse dependencies because that's where we have shared state for our environment. Cool. All right, let's do it for real this time. So we're going to change this to unwrap and we're going to call the right token. Sweet. So our contract is working as expected. One of the nice things I like about doing the happy path test, and maybe this is just like my own personal workflow and figure out what works for you, is that I just writing this like one huge test, but usually I have all this stuff that I need and I can break it out into like kind of nicer tests. So after I get done with this, I'd probably go through a phase where I would break out these kind of edge cases into separate tests. Just also, I think about it in terms of readability. Okay, happy path, that's not very descriptive. Whereas, okay, proper instance initialize, like you can just make much more descriptive test names and that's helpful. And another thing is we'll probably just keep growing this happy path as we add more functionality to this contract. Cool, we're doing really good. I guess we gotta keep going, right? All right, this next one's gonna be a little bit challenging to test in a unit test kind of environment. And I will explain why. So what we're gonna do now is we are going to test burning NFT returns money. And actually, whenever I think of tests, I usually just write them down. But we are going to test that only the owner can burn the NFT, and we're going to test that it might be a little bit redundant, but we can test that we can't burn an NFT that doesn't exist. Because that could be a problem. So let's say there's like money in the contract and maybe it's a little bit overly paranoid. One of the things we can be mindful of, at least in this particular contract that we're working in, since we're using the CW721 base contract, that does a lot of checking already. Like for example, this checks ownership. We don't really have to worry about that. In fact, we could even just not write a test for it, but we're going to write a test for it anyway, we're actually going to get rid of this to do. We're going to check ownership anyway, just to make sure that this is working, right? Cool. This seems like a pretty good bit of checks. Can anyone think of anything else we might want to test? And then I think once we get to this last one, we have a pretty good working contract.
Depositing to a token ID that does not exist yet. That would result in an error.
We're just going to do that one really quick because we already have the message ready. I notice I'm doing like unwrap error for all these. I could save the result of this, for example, like let response, and then I could then do another test and there's a great video on Rust testing libraries. Rust testing. It's great. It's all just amazing. So you could do something like assert, like equal, and then you could like let's say we want to make sure that probably wouldn't call it response here. We'd probably call it error, but you could just make sure that it's a particular type of contract error, for example. But I'm lazy, so not going to do that. Sometimes you want to do that though. Like you want to just make sure it's a particular type of error. So you could add some extra conditions there. So can't deposit a token ID that doesn't exist. We're going to do that. We're going to fix the other thing that's wrong, which is sometimes it is good to check that the error message is the right one. We're going to be lazy here, but for example, if I did this and unwrap error, I might actually not be testing that this is working appropriately because this is still broken. So we're going to fix this. Actually, fuck it. Let's just do for example, we're going to do let air, and then we're just going to do assert equal here. Air, contract air. I actually don't know what air this is, but I think it's actually a standard air. We did it with a loading test. Whenever I don't know what type of the thing is, okay. You can always just check what the type is in your editor. So this is probably still going to be wrong, but it'll tell us how we can make it right. Sometimes it's good to write tests that you know will fail. All right, that's what we need. Probably could make this a little bit cleaner and make a nicer air response, but that can be a to-do for later. Right now, this will work. Oh, look at that fun air. Okay, cool. So basically, it's not found, and the type of thing it's not found is token info, and it says exactly which token info. So at least it's very precise. It's like this library, this piece of state, this configure, this extension. That's an example of how you can do a more concrete, less lazy air check than unwrap air. Cool. All right. So only owner can burn the NFT. I'm also going to just basically copy that. We are going to not provide any coins this time. So we're going to make this empty. We don't need this. So this is only owner can burn the NFT. So we're going to just make a random person here. Rando. Like Lando, but it's Rando. And again, I've got my little strings are fun. I don't like strings. Perfect. So we can see that this is the right air here. It even tells us what kind of air it is. So we could do a more accurate air check here, but we did that above and I'm lazy. If anyone wants to make a pull request to do this kind of more, like this is like the more proper thing, like you want to unwrap the air and make sure it's the kind of air that you expected. But this is good for the hacky one. Anyway, if anyone wants to make a PR with for practice to like improve these tests a little bit and like actually check the errors, that'd be great. But yeah, so this is working now. Sick. We're going to change it back to Bob because Bob created the contract and we're going to just go with token ID 2, right? Actually, I'm just going to do the same thing. I'm just going to just make sure it's the thing I expected. We probably should be, yeah, that's great. Actually, I'm going to set a good example, especially because the air is the same up here. So we can be lazy about it. This is how you should do it. You should always check that the air is what you expect it. Oh, let's see. Oh yeah, because that makes sense. There we go. Oh, I see what I'm doing. Oh my gosh. Okay. So usually when something like is wrong, Rust tells you exactly what is wrong. So looking at our check here, it says the values don't match. On the left side, we've got this CW721 error, which is, if we look at our contract error struct, that's it. Then here I'm just passing a standard error. So they are different types. They're actually really similar. Like this whole part is like the standard error part is like completely similar. So basically I have to come over here and wrap this in contract error.
So you're comparing the first part and not the kind,
Yeah.
because they have the same kind. It looks like.
They're wrapped in something different.
Gotcha. Yeah.
This is where Rust type stuff is always fun. Here we expected a CW721 base contract error and found contract error. So we can just, usually it always says exactly what you're supposed to do. You just have to read through this oftentimes confusing gobbledygook, and it basically tells you what you have to do. So yeah, this one was wrapped in our normal contract error, and then yeah, I don't want to get into the weeds too much, but usually when this stuff happens, it always read this red lettering will tell you exactly what's wrong. It's like, I expected this, I found that. A lot of times it'll even tell you like what you can do to like, fix stuff. And just a sec, I have my girlfriend calling me. Cool. All right, so let's test burning this NFT and making sure it returns the money. All right, so this time we're gonna have Bob burn it. And he's gonna burn a token that actually exists. And we're just gonna unwrap it. So this should succeed. Yes. Oh my gosh, we did it. Our contract works. But did it work? How do we actually make sure that things are working correctly? One of the limitations of unit tests is we don't have a whole blockchain, right? We don't actually have like Bob's balances on the blockchain to like check here. We're just purely passing things into functions, right? And the dependencies, while they're cool, they keep track of the contract state. They don't actually implement like a whole mock of the entire blockchain. That's where multi-test is really interesting. I think multi-test actually has like balances and things like that. But for unit tests, we don't have all that. So how are we going to possibly test this function? Does anyone have any ideas or? All right, spoiler alert. We're going to look at the response. Okay. So we execute the thing, we unwrap it. Now, sometimes it's helpful to just actually do like the old fashioned, you've done this before. Just let's look at it. Let's look at the response. Sometimes if I don't know how to test something, like I'm not above a good old fashioned print statement for debugging. Fucking love print statements. They're great. how do you get print statements in Rust? It's a little bit annoying, but you have to actually, when you're running your tests, like a lot of these are suppressed. So you have to oftentimes pass in this -no capture flag. And then we will see our response printed out. So as we can see, our response has a messages struct. Inside of that struct, there is a sub message, and oh, here it is. Here's that bank send. So this is a message to the Cosmos SDK bank module to send this money. So the fact that this message exists means that we're probably good. This worked. So we can look at this response, and now we can write our message accordingly. You could also just do this with like auto completion in your code editor, but we're going to do another assert equal, and we're going to assert that the response messages the first item of that. That message. Okay, cool. And we're going to make that it's gonna be Bob, and it's be for oh.
Amount should be a coin.
Oh my gosh, that is I've got so many times. We're actually going to use our helper here. So we could just do the coin type, but the helper's nice. We need it. This is amount is a vec of coins. So if we, again, the great thing about Rust is everything has types, and the types are really strict. So you can always look at the types, and if we look at the send message, it's taking a list of coins. So now, do that now. Let's run it again. Okay. It expected an enum Cosmos message, but it found enum bank message. So that's because our types are a little bit different. We're really close. Let's wrap this in a Cosmos message. And we're just going to throw this in here. And now it should work. Sick. All right, we've got ourselves some work-in tests. We can now feel confident that our contract is providing the basic functionality as it should. Let's do a little bit of cleanup. So we've got this unused import here. We can see it's complaining about it right here. I'm not going to make our code bad or anything, but might as well get rid of it, clean it up. Another thing you can do is cargo Clippy. Clippy is an amazing tool. I actually implemented Clippy in the CI for the Code and Chill project. It's going to run every time anyone pushes code or opens up a PR. But Clippy will complain about like everything, but it's happy. And when Clippy's happy, that means things are probably really good. So this code compiles. It's probably going to do everything we want it to do, which is sick. Let's clean up some of our to-dos. I think next time it'd be more fun if we focus on the dynamic of charging up the NFTs. And we could potentially make more variations of this. If someone wants, you could take this base contract and you could make it into a DeFi NFTs contract. And if you're doing DeFi NFTs, you might decide to like make this hold like multiple tokens. I think we were thinking of a game early on. So I think it'd be more fun to, in the next steps, focus on making like the appearance of the NFTs be more dynamic based on like how much is in the NFT. So just cleaning up some of our comments again. We just don't really need it.
Is the transferal of the NFT going to be in scope here? Something we want to test for or build?
Oh, that's already built.
I didn't realize that.
So we're building on top of the base implementation. And the event that is we don't actually have to implement all that ourselves. It's handled by the default CW721 contract here.
Cool. So we don't see it.
Yeah. So that's the really cool thing about building on the base is so you could just take a contract and then just like fork it. But building on the base is nice because like new things get added to the base a lot that like make it more powerful and like secure and things like that. And we just don't have to worry about any of that. We can just call the base instantiate method, or we could call we don't have to worry about handling transfers, or the NFT spec also has this really complicated stuff around approvals. Approvals are really like this like big thing in NFT contracts, and it's pretty tricky to code. And so not having to worry about that like really actually just makes it a lot easier. So yeah, the template that I gave you like basically just has like the kind of basic structure in place. In fact, this is a good example because it shows you like this is the default implementation. So when we match the message, when the message comes in to execute the contract, we look at it. If it's a burn message, we're going to override that. So this is overriding the default burn implementation. If it's part of our extension, we're going to handle those here. So that's where we do our deposit. And then everything else we pass off to the base implementation. So like transfers, etc. Now let's say we wanted to like override minting, then you would just do execute message. You do mint, and then we would just override that. Just do whatever we want to do to maybe we want a different type of minting flow or minting that's only possible like under certain conditions. For example, you could make an NFT contract that's only possible if it's only possible to mint if you burn like 2 other NFTs. So like the high level is like, okay, we're good. Yeah, I hope that makes sense, right? We're building on top of a base contract. And so we only have to focus on our custom functionality. We don't have to focus on like transfers and things like that. And if you want to, you can always come down here and we can just be like, but sure, transfer works. Okay. So we're going to transfer the NFT from Bob to Jim. And it's going to break the rest of our test. So the part that breaks will not be, see, now the test on 404 is breaking, which is good. The transfer worked like beautifully. Just to show that like all the base functionality is like already implemented. That's another thing we can do. Just as a little bit of cleanup. We don't actually have to use the base extension here. We can actually just get rid of that. Make things a little bit cleaner. It's always great to make things a little bit cleaner. There's always a lot of text to look at. And the cool thing is they're equivalent. That's really the whole thing about building off the NFT standard is that you have this sort of basically equivalent API for all the different NFTs. So the really basic stuff like transferring approvals, interacting with smart contracts and stuff, that's all standardized, which is great. Don't make your own NFT standard. Any questions? Silence. Everyone's speechless.
Well, did you cover a lot of stuff?
It was a lot of stuff today. Yeah, let's look at it. Let's see. We did a lot of stuff. We made a custom instantiate message that added our deposit denom. We created a new piece of state to store the configured denom for the contract. We saved that. We did our like kind of basic refactor everywhere to use that as many places as possible. We improved our balance query to return a full coin type instead of just a number. We fixed up our tests. We actually tested some stuff in like a big giant test, but as long as tests are written, still better than nothing. But yeah, we tested a bunch of edge cases. Look at all these cases we tested. For a lot of these, it'd probably be good to, it'd be a lot nicer to look at them on this screen if they were all listed under multiple tests instead of just happy path, but whatever. Yeah, if someone wants to like have a go at refactoring these tests to just clean them up a little bit, maybe break them out into like individual tests, it's sometimes fun to just take apart like already working code and trying to improve it or add something else. If anything, like the great thing about Code and Chill repo is that you can make PRs and you'll have like people look at them for free and give you comments and feedback. So why pay to go to college when you can just like do stuff and learn? We're just going to call this Code and Chill 2 work. Sick. Oh, and then I'm just going to push that. Great. We just put all the work we did to Git. Yeah, let's take a quick break for discussion and questions. If anybody has any.
Yeah, nothing here for now. Just excited to, once you push it, I'll just start playing with it more locally. But so far, so good.
Cool. Since you guys are still here at the end of the video, I want to give you some alpha. Actually, I'll just stop screen sharing, which is we're launching a developer guild. Okay, so you guys familiar with guilds at all? Like from like medieval times or like anime or something?
Yeah.
Yep.
You think best way to build community is just culture? We want to just get more people like hanging out, teaching people things. And so we're launching, I think there's actually many developer guilds in Ethereum, but come to think of it, I cannot think of one developer guild in Cosmos or like one like just developer like DAO in Cosmos. And so obviously we got like DAO and stuff. Time to make a really sick developer guild. And so Elite Society, it's going to probably launch next week. And there's going to be like basically 3 tiers. There's going to be the master level, like people that have contributed to like significant like open source, like major projects. And they're really cool. So we have Zeke and Noah from DAO. We have Reese, myself, and then a 5th mysterious person who will be announced. And that's a pretty like sick lineup. Zeke is probably single-handedly like the best CosmWasm dev out there and is like probably like 100x better at Rust and all this stuff than I am. I'm just like one of those all-rounded like people that's like good enough at enough things, but not insanely good at anything. But yeah, so Reese is great. Noah is amazing on like the front end. So we're going to be also doing Code and Chill for like how do you connect? Okay, great. We made this contract, but how do we actually connect this up to things people can actually use? And then Reese is just like amazing at infrastructure. And then I'm excited for the 5th mysterious guest, but I cannot give out all the alpha. And then we're probably going to be just like growing that as time goes on. Then there's the next level is the journeymen. These are people that have a certain, like some amount more of experience. They can write Rust. They've written a couple of smart contracts. They're on their way to becoming masters. And finally, we have the apprentices, which are just like the entry level people, the complete noobs. And it's fun. It's great to be an apprentice. Everyone starts as an apprentice. And I think this will be a really fun system. Everyone's going to get really sick cyberpunk hacker NFTs. And we're going to make them talk and stuff. I actually posted like a little promo video in Elite Society. I don't know if anyone saw it, but I think we can make them like really sick. And I think the big thing is I want to just create a space where we can learn from each other and hang out, but also just find people to collaborate with on. I'm always looking for great developers. And when people prove themselves, they get opportunities. And that social network is just super invaluable. And I think we really need it in Cosmos. So it'll be a great way to meet people, get access to opportunities. There is going to be like some cool compensation systems we're going to be implementing. So retroactive rewards. So every certain period, I don't know if it's going to be monthly or quarterly. We're still figuring some stuff out, but basically it's going to be anyone, all the apprentices can basically submit their work to the journeyman, and the journeyman review the apprentices' work and then assign them points, and then they're paid out according to their points. And then the same thing for the journeymen submit their work to the masters, they get feedback, and then again get assigned points, and they get compensation according to their points. We're also working on a badge system as well. So as you go about doing things and achieving certain things, you'll earn NFT like reputation badges that you'll be able to show to people that you actually know what you're doing. And hopefully that lands you a job, or even better, who needs a job when you're in Web3? You could just find really cool people to work with and launch the next like multi-billion-dollar protocol. So yeah, I think it'll be a lot of fun. I think it'll be a good little experiment, and we got some cool people in it. So really looking forward to
Sounds cool.
building culture with all you guys. And so, yeah, I think it'll be fun. And we might even launch some projects as a guild. So I think who knows, maybe the CW Piggy Bank thing could like actually turn into an actual project. And if it's launched by the DAO, or if it's launched by Elite Society, proceeds go to Elite Society. So join a DAO, the future.
Big. Good marketing stick. Good skill. I'm in.
Yeah.
Fuck yeah. All right, cool. I'm glad you guys are in. I'm getting emoji actions from Little D, so I hope he's
Real
in.
TD.
Let's go. But yeah, more on that like next week. And yeah, I think it'll be a blast. I think we're gonna have a lot of fun with it. And I think it's just mostly just about making good connections and finding cool people to work with. So anyway, shit, my girlfriend's downstairs, so I have to go talk to her.
Yeah, good session. Thanks.
Yeah, it was great. Thanks, guys. Later.
Later.
Peace.
See you guys.